Hello everyone, welcome back to the channel. Today, we are diving deep into one of the most feared unmanned aerial systems in modern warfare, Israel's Harpy drone. Known for its precision, persistence, and lethal capabilities, this drone has made a name for itself as a loitering munition, causing significant concern among military experts worldwide. Unlike conventional drones, the Harpy is designed not just to gather intelligence, but to seek and destroy Hive-Al-U targets autonomously, a feature that sets it apart from most UAV in service today. The Harpy drone was first developed in the 1990s by Israel Aerospace Industries, aiming to counter enemy radar systems. Its primary mission is the suppression of enemy air defenses, often referred to as SEAD. By autonomously detecting radar emissions and then directly striking the source, the Harpy can neutralize threats without putting human pilots at risk. This combination of autonomy, precision, and lethality is why it has garnered attention from militaries across the globe. Weighing approximately 135 kilograms with a wingspan of 3.1 meters, the Harpy is relatively compact for a weapon system of its capability. It is designed to be launched from a ground vehicle, aircraft, or even a ship, giving it immense operational flexibility. Once airborne, it can loiter over a target area for hours, scanning for radar signals. This endurance allows it to patiently wait for the right moment to strike, making it particularly dangerous to fixed radar installations and air defense networks. One of the key features that terrifies military analysts is its autonomous targeting system. Unlike drones that require constant human input, the Harpy can independently identify and engage targets. Using advanced sensors and onboard computing, it locates radar emissions, determines their importance, and dives into them with high accuracy. This level of autonomy reduces the reaction time of enemies and forces them to consider constant radar shutdowns or mobility to avoid detection, which in turn limits their defensive effectiveness. The Harpy's warhead, although relatively small at 15 kilograms, is designed specifically for the destruction of radar equipment and soft-skinned targets. When combined with its autonomous loitering and precision strike capability, this warhead can incapacitate a radar site with a single hit. Military experts often point out that such drones redefine modern air defense strategies, as traditional anti-air systems are less effective against a small, autonomous, and patient hunter like the Harpy. The psychological impact of the Harpy is another reason for its notoriety. Military personnel operating radar systems or surfaced-ware missile sites often describe a heightened sense of vulnerability when facing loitering munitions. The knowledge that an enemy drone could be silently circling overhead, waiting to attack, forces changes in standard operating procedures, from constant radar shutdowns to dispersal of equipment. This kind of disruption is as valuable as the physical destruction the drone can cause. Harpy drones have been exported to several countries, including India, South Korea, and Azerbaijan, often as part of broader air defense modernization programs. Their appeal lies in the fact that they are both cost-effective and highly efficient. Compared to deploying manned aircraft or more expensive missile systems to neutralize enemy radars, the Harpy can perform the same task with minimal human risk and lower operational costs. The operational range of the Harpy is also noteworthy. Capable of traveling over 500 kilometers from its launch point, it can cover vast areas of the battlefield. Combined with its loitering time, which can exceed 6 hours, it can operate across multiple targets in a single mission. This extended operational envelope makes it a force multiplier for any military force that possesses it, allowing for simultaneous or sequential attacks on critical enemy assets. Another remarkable feature is its countermeasure resilience. Modern air defense systems rely heavily on radar-guided interception, jamming, and decoys to neutralize incoming threats. The Harpy is specifically designed to seek out radar emissions, which are the very signals used to track or jam aerial threats. Its ability to home in on these emissions means that traditional countermeasures are often less effective. In some cases, employing electronic warfare tactics can inadvertently make a radar system a bigger target by drawing the Harpy's attention. The deployment tactics of the Harpy vary depending on the battlefield environment. In high-intensity conflict zones, multiple drones can be launched simultaneously to saturate enemy air defenses. By overwhelming radar networks with several autonomous loitering munitions, militaries can create gaps in coverage, allowing manned aircraft or other weapon systems to operate with reduced risk. This kind of integrated warfare approach has been studied extensively by military analysts as a model for future conflict scenarios. Training for operating the Harpy is intensive but manageable due to its autonomous capabilities. Operators are trained primarily on mission planning, target selection, and monitoring, rather than direct flight control. The autonomous nature reduces the complexity of real-time operations, allowing a small team to effectively manage multiple drones simultaneously. This operational simplicity, combined with sophisticated technology, is part of what makes the Harpy such a disruptive system in modern warfare. Over the years, Israel has continued to refine the Harpy platform. Variants such as the Harop have emerged, featuring improved range, enhanced sensors, and more precise targeting systems. These improvements extend the drone's lethality and operational flexibility, making it an even more formidable threat to enemy air defenses. The evolution from early Harpy models to modern derivatives demonstrates the ongoing emphasis on autonomous, high-precision loitering munitions in contemporary military doctrine. Military analysts also emphasize the Harpy's role in shaping regional power dynamics. Nations that possess such technology gain a distinct advantage in both offensive and defensive operations. The ability to neutralize sophisticated radar systems without risking pilots or expensive aircraft shifts the balance of power, particularly in conflict zones with heavily defended airspaces. This strategic leverage is one reason why the Harpy continues to be a focus of international arms discussions. Despite its capabilities, the Harpy is not without limitations. Its reliance on radar emissions makes it less effective against targets that operate stealthily or intermittently. Mobile or hardened targets can sometimes evade its precision strikes. However, the drone's endurance, autonomy, and flexibility often compensate for these limitations, allowing operators to adapt tactics and achieve mission objectives even in challenging environments. The Harpy has seen operational use in various conflicts, although specific missions are often classified. Reports suggest that it has been effective in disabling enemy radar installations, contributing to air superiority operations, and facilitating safer routes for manned aircraft. Its real-world performance reinforces the theoretical advantages military experts attribute to loitering munitions and continues to influence defense planning worldwide. From a technological perspective, the Harpy represents a significant achievement in autonomous systems, miniaturized sensors, and precision guidance. The integration of these components into a compact, efficient drone capable of independent decision-making reflects broader trends in military robotics and artificial intelligence. Analysts predict that future iterations of loitering munitions will continue to push these boundaries, making systems like the Harpy a benchmark in unmanned warfare. The threat posed by the Harpy also drives innovation in counter-drone technologies. Militaries are investing in electronic warfare, directed-energy weapons, and enhanced radar networks specifically to counter autonomous loitering munitions. This technological arms race between offensive drones and defensive systems underscores the transformative impact the Harpy and similar drones have on modern military strategy. Public perception of the Harpy is shaped largely by its mysterious and autonomous nature. Media reports often highlight the drone's ability to operate without human intervention, its precision strikes, and its psychological impact on enemy forces. This combination of technical prowess and strategic effectiveness has cemented the Harpy's reputation as a fearsome asset in any military arsenal. The ethical considerations of deploying autonomous lethal systems like the Harpy are also a topic of discussion among scholars and policymakers. The drone's ability to select and engage targets without human oversight raises questions about accountability, collateral damage, and the rules of engagement in modern warfare. While current use is largely focused on military assets, these debates continue as technology advances and autonomous capabilities expand. In terms of battlefield integration, the Harpy is often used in concert with other surveillance and strike systems. By coordinating with manned aircraft, electronic warfare units, and intelligence gathering platforms, militaries can maximize the impact of loitering munitions. This networked approach increases mission success rates and reduces the risk of counterattacks, demonstrating the strategic value of combining autonomy with broader operational planning. The cost-effectiveness of the Harpy is another factor in its widespread adoption. While advanced compared to simple drones, it is significantly cheaper than deploying manned strike aircraft or missile systems for the same missions. This affordability allows even mid-sized militaries to access high-end capabilities, leveling the playing field in certain conflict scenarios and making the Harpy a disruptive factor beyond the Israeli military alone. Looking ahead, the development of loitering munitions like the Harpy will likely continue to shape modern warfare. Increased autonomy, better sensors, longer loiter times, and enhanced precision will make future variants even more capable. Militaries worldwide are studying the operational lessons of the Harpy to inform procurement, training, and defensive strategies, ensuring that this class of drones remains central to the evolution of aerial warfare. In conclusion, the Harpy drone represents a revolutionary approach to modern combat, combining autonomy, precision, endurance, and psychological impact. Its ability to neutralize enemy radar without risking human pilots makes it a formidable tool for any military force. While not invincible, its effectiveness in real-world operations and its influence on military strategy are undeniable. As autonomous loitering munitions continue to evolve, the Harpy remains a benchmark in understanding the future of aerial warfare and the shifting balance of power in conflict zones around the world. The enduring legacy of the Harpy lies not just in its technical capabilities, but in the way it forces militaries to rethink traditional defense strategies. By challenging conventional radar and air defense doctrines, it has reshaped tactical thinking and operational planning. In doing so, it exemplifies the transformative impact of autonomous weapons on 21st century warfare, leaving military experts both impressed and concerned about what comes next.